Hello everyone, this is your boy Winsweb here, and in today's tutorials we are going to build a simple image classification app using TensorFlow. After that, we will make sure to convert the save model into a TF Lite so that we will be able to deploy this model inside our Flutter app. So let's look at what we are going to build in the mobile app section. So this is my mobile app, a beautiful UI. I can pick image from the gallery. So let's say I pick this one, and you can see we have a bacterial spot disease which is affecting this pepper leaf. With this image classification app, we are dealing with 5 classes. So we have diseases for pepper and diseases for tomatoes at the same time. So I guess this one will be a healthy pepper leaf. So this one too might be tomato. Yes, so bacterial spot for tomato. So we have early bright for tomato leaf. Guess this one will be a healthy tomato. Hello everyone, it's your boy Winsweb here. And in today's tutorials, we are now going to build our image classification model using TensorFlow. So with this video, I assume that you already have a little bit knowledge about Python programming and deep learning in general. So if you are getting a little bit confused, you don't know anything about deep learning, I recommend you to watch this video. From 3 blue, 1 brown. Here in this video, we did well explaining deep learning and neural network in a way that I can't explain it. It's a very nice video. And also, you can watch this simple image classification model if you just want to get things done very quickly. Here, I built a simple image classification model using teachable machine. But with this one, we are going to use a real Python code. So let's get into the cells and let's run it. And I'll explain along as we do so. So with this first cell, this contains all my imports. So as you can see, I have my TensorFlow, and I'm also using matplotlib for plotting certain data out, and I'm also using NumPy too as well. So with this cell contains my data directory. So as you can see, we have this data set. So this is my data set, and within this data set, we have the following folders. We have for the pepper and the tomato. So meaning I'm having 5 folders inside this dataset directory. And I'm having my hyperparameters. So as we are going to train this model, we are going to pass the image in the form of a batch. And we need to set our image width and height too as well. But since it's going to be in the form of a square, that's why I have my image size to be 180. So I'll use it to represent both my height and my width. And I have this number of epochs also set to be 20. So meaning I'm going to train it under 20 epochs. But with these hyperparameters, you can feel free to change it and see how and see the type of impact that you will get at the end of you training your model. So I'm using this. So in this cell, I'm loading the data sets by using image dataset from directory. So it is from this Keras API or from TensorFlow, which we are loading this image from directory. And this, as you can see, the location of my image. And I'm splitting the image. I'm making a subfolder which It's called training, and I have my image size. So I'll pass in for the height, and this one is for the width. And also I'm having my batch size, which is 20. Sorry, which is 32. So let me run these cells. And so as you can see, we have 700 and we have 7,193 images or files, and we are using 5,765 files as our training data set. So this also represents our validation data set. Here in this validation data set, as you can see, we have split it like similar thing that we did for the training data set, but this one is now called validation data set. This one is now called validation because it's for our validation data set, and we have our directories, and also we have our image size, and we have our batch size too as well. So here we are using the remaining we are using the remaining 100 and we are using the remaining 1,438 files for the validation. And this is our classes. So let me run this one and run this one too. So we now have our classes to be the names of these folders, as you can see. So we have the paper, which contain this file, and all these files contain images of what we are going to train. So as you can see, yes. So we are doing a simple data visualization. We are just plotting the data to see how, or to see if each and every single image is linked to its class. So as you can see, we have the bacterial spots pepper leaf, and we have the healthy tomato leaf too as well. So let me run this cell. And here too, as we have down here, we are just checking our image batch and our label batch, right? So with our image batch, we have 32 batches, and we have our height and our width, and we have these three which represent the channel. So this is a colored image. It's an RGB image. It's a colored image. So that's why we have three here. So if it was supposed to be a black and white image, then here will be one. So meaning we have only one channel. But with this one, we have three channels. So we are doing data configuration. Here we are shuffling the training images. We are tweaking the training image a little bit and preparing it so that we will be able to train it very well. But with this validation, we don't have the SAFOR, but we have the perfect, and we are also doing caching too as well. So if you don't understand all these things, I'll make sure to leave a link where you'll be able to read more about these functions. So we are doing data normalization. So with this data normalization, the RGB is in a range of 0 and 255. But since we are going to use a neural network, we need to make sure that our images is in a range of 0 to 1. So with this data normalization, we are able to process our image to be in the range of 0, and this is 0.99. So let's say almost 1. Yeah. And it does not fall between 0 and 255. So I guess it's cool. So here we are doing data augmentation. why this data augmentation? Since we are going to train this in a neural network, we need to make sure that the model will be able to see the data from different angles. Like we are doing flipping, which in this case is a horizontal flipping. We are doing random rotation, and we are doing random zooming too as well. So the reason behind this data augmentation is sometimes your model might overfit. So if I talk about overfitness, meaning the model did not perform not just well, but it tends to be confused. But with this data augmentation, the model will be able to see the image from different angles. And from there, it will be able to train the image very, very well. So we are going to do transfer learning. And with this transfer learning, we are going to use MobileNet V2. So this cell here will load the MobileNet V2 model for us. And we are going to set trainable to false, meaning we are going to freeze the layers. And this is how we are going to set up the model architecture using the MobileNet V2. Since I said we are going to do transfer learning. So our main focus will be in this output section. Here in this dense layer, we need to make sure that we are passing the number of classes according to what we are doing. The number of classes that we are working with is 5. So I'm having 5 classes. So that is the reason why I'm passing 5 down here. So this 5 represents my number of classes. So if you are working on a project and let's say your number of classes is more than 5 or less than 5, make sure to replace this one with your number of classes. Then with the model, we set our inputs and our outputs. So let me run the cell that I haven't run yet. So let me run all these ones. And let me run this one too as well. And let me run the model. So we are now summarizing the model. So this is our model summary. So there's a whole bunch of models that we can work with. But here we are just going to use MobileNet V2. And before we will train the model, we also need to compile the model. So we need to choose our loss function, which here I choose spark categorical cross entropy loss. We have our optimizer. Here you can choose Adam optimizer, or you can choose any type of optimizer that you want. And just to see how this optimizer is going to impact the final results of the model. And we are also going to keep track of the accuracy metrics during the training section. So we just have this simple callback function, which we are going to use it to save the best score of our model. And it's now time for us to train our model. So for us to train our model, we have this history parameter. So we are saving all our training section in this history parameter, right? So let's train the model. As you can see, we are passing in the training data set, and we are passing in the validation data set, and we are passing in the callbacks and the number of epochs. So the difference between this training and this validation data set is, as the model is training, after going through one epoch, it will take a validation data and then see how well that it did perform while training. And that is the reason why we will be able to save all our best scores inside this callback function. So let's see how the model is training. And we are still in, we are still on our first epoch. So let's wait for the model to train. So we now have our first epoch completed. And this is the accuracy for the first epoch. So as you can see, this is the accuracy for the first epoch, and this is the loss for the first epoch. And we have our validation loss and our validation accuracy. So our validation accuracy is 95, and we have our validation accuracy, sorry, our validation loss too as well. So this is what I was talking about. So as you can see here, right? So we now have our best code being saved inside this H5 file. So we have our plant model MobileNet V2 H5, and this is the file. So we are saving all our best scores inside this file. So we are now at our third epoch, and as you can see, the accuracy is what? 91, and the validation accuracy is also 91 too as well. So let's wait for the model to finish training, and we will continue from there. So our model has finished training successfully, and we have now hit our 20 epochs. And yeah, it took much longer than I expected. So this is another way of saving the model. With the first way of saving the model, which was using the callback, we were saving the one with the best score. So with this one too, if you want to save the entire model, which is this one, if you want to save the entire model, so you can use model.save to save the entire model. So let's save the model, and our model has successfully saved, which is plant model.h5 model. And with this cell, we are now converting the entire model. So we are now converting this entire model into a TF Lite model. I didn't use the best score one, I just used the entire model. But that one also worked actually great. So I could have loaded that one into memory and then converted it into a TF Lite model. But I guess this one was very nice. So let's use this one. So we are saving the plant H5 model into a TF Lite format. So this is the name. So here you can change this name to whatever that you want. And I guess it will nicely display here. So let's wait for the model to convert into a TF Lite format. So yes, we now have our model neatly converted into a TF Lite format. But let's run some simple evaluation on our model and see how it did perform. Like we should have even done that one before saving the model, but since I've already go through the code and see how and know how well the model performed, that was the reason why I did it. So first, let's load this dataset image. So I'm taking the test dataset, which I'm pointing towards this directory. So this is a dataset that the model haven't seen yet. So that's the reason why I'm having this one in a separate folder. So with this one too, I'm having 5 classes as usual, and I've now loaded the dataset. So let's run some simple evaluation and see. So as you can see, our model has performed around 98% accuracy in our evaluation in the evaluation process. So with this, let's now plot our data and see how the model or how things are in the graph. Okay, but the graph looks a little bit weird, but trust me, the model did perform very well. So I guess maybe we would then run some tests by using the test data set. So let's do some simple prediction and also see how our results, so that you'll be able to compare it with the graph to see if the model has performed well. So I'm having this function which I'm going to use it to do our prediction, because I want to predict the model with a certain number of images. So I guess building this function will help. So with this function, now we can now plot our images and against its prediction to see how the model did perform. So we have the actual label, which is tomato early bright, and we have our predicted image, and we have our confidence level. So as you can see, actual label, predicted label, and the confidence level. So I guess the model has performed very, very well. It is getting everything as we were expecting. So yes, with this, we can now see that our model is performing very well, even though our graph is a little bit red. But I guess maybe training it with uh, with much higher epochs might bring a little bit changes in the graph. So yes, we now have our TF Lite model, and we now also have our H5 model. So in the next video, I'm going to create a Flutter app which will make use of the TF Lite model. And also, I'll also deploy this model using Fast API, which we will use React application to make use of this H5 model as well. So thank you for watching this video, and I'll see you in the next video. I know that you are all doing awesome. So I'm very glad to continue from where we left it the other time. So if you didn't watch the previous video, what we did was we created our own image classification model from scratch using TensorFlow. So it was a Python project. And after that, what we did was we saved a TF Lite model, which we are now going to use in our Flutter application. So before we will build the app, let me spend, let's say, a second here to talk about this plugin. So this is the TensorFlow newly released plugin. So this one was released around August 2023. Yeah. But I'm not going to use this plugin for this video particularly. The reason is I've already used this plugin, and like I've been getting messages about errors and those stuff. So I just want to maintain it. Yeah, I just want to maintain it. But I'll make sure to do video about this plugin as to how to use it to do simple TF Lite project. So with this, I've already built this template, and this template is similar to the template that I used when I was creating the image classification model using Teachable Machine. And this is the video too as well. So if you did not watch that video, I'll make sure to leave a link where you'll be able to watch the video and see how the UI was built. Also, this is the source code too for the project. And with that, I'm going to use image picker package and Flutter TF Lite, the same versions like the other one, because I was having a whole lot of messages about the versions and some challenges that some of you were facing. So I want to address it. Due to that, I'm using the same version. And this is the whole package. So if you find it useful, please don't forget to leave a like at my GitHub page. So yes, let's build the app. This is the code template for the UI. It's not anything heavy, but I don't want to go through that code. But first of all, let's change this one to be plant disease prediction. Well, the other one was mango disease prediction. So this one is plant disease prediction. So let's change the heading, or let's change the title. And since we have all our packages, so let me go to the popspark.yaml for you to see. So I've made sure to enable my asset so that I'll be able to make use of the asset folder. And also, I'm using similar version. I'm using the same version like the other one in my popspark.yaml. And since we now have all the packages that we need, let's start by building up the functionalities of the app. So first, let's set a file. So we'll have a file which I'll name file path. File path. But make sure that the import type is from .io. So make sure that you import from .io. And with this, let's create a function called pick from gallery. So with this function, it is going to be of type async because you are going to make a certain call which we will need to await for a certain number of time before we will be able to continue the process. So since we have it, let's now make sure that we are. So since we have this, let's initialize our file picker, or let's initialize our image picker. So we are going to use final image picker, which I'll call picker, and then set it to image picker. And after that, I'll also have final X file, which I'll call image. And here we need to await on our picker pick image. So the source will be image source dot gallery, like this, because you are picking the image from the gallery. So here what you do is you check if the image is null. So if we have image, so it's going to be image equals null. So if the image is equals to null, therefore we will return very quickly. And if it's not equals to null, we will set an image which I'll call image map to be file image.path, like this. And here we will set a state for our file path. So file path is equals to the image map. So we now have, if we are able to pick the image successfully, therefore we will save it inside this our file path. So with this, we will now be able to use the file path to replace this image. So where was the functionality that replaced this image? Let me search for it. And okay, so here let me make sure to call my pick image from gallery to enable this button. Just below our box decoration, we need to check if our file path is equals to null. Equals null. I don't know. Therefore, what we will do, we will return an empty text. But if it's not equals to null, therefore I will return image.file, and then I'll pass in the file path. File path. I'll force unwrap it and set it to fix box fix dot fill. So let's save it and let's make sure to do a hot reload to see if our functionality will work as planned. So let's see if we'll be able to pick image from the gallery. So as you can see, we now have our gallery open match successfully. Let's pick any of the image to see if it will replace it. And yes, so we now have the image replacement happen very successfully. So let's copy this same function and change it to pick from the camera. So we are now picking the image from the camera. So we are now picking the image from the camera. So here the source will be camera, like this. And I guess this is all that we need to do for this function. So let's make sure to call it where we are picking the image from the camera. And let's save the app to see if we'll be able to launch the camera. And yeah, we now have our camera launched successfully. We can take a picture and load it. So I guess our functionalities for picking the image and displaying it is working successfully. So it's now time for us to make use of the Flutter TF Lite. So with this, and with this, I'm bringing in this function. And then let me make sure to import Flutter TF Lite. So with this function, we are calling our load model, and then we are getting the location of our plant TF Lite, which I need to bring into the asset. So let me bring the plant TF Lite. Yes, this is it. So this is the plant TF Lite. Let me drag and drop into our asset. And here we need a label file. We need to create a file in our asset and name it label. But you can choose to name it whatever that you want. So let me do it file.txt. And where can we get the labels? So the labels, when we're creating the model, this was our label. So I'm going to copy this whole section, this class name, and drop it here. So let me make a little bit of changes. Yeah, so after cleaning up, this is what I have. And let me save this file. So let's get back to the main.dat file. So we are now having access to our TF Lite model. We are also loading our labels too as well. And let's make sure to dispose the TF Lite. So let's dispose it. So let's dispose it, which will be TF Lite dot dispose or dot close. Sorry, so let's dispose the TF Lite, and also let's set an init state for it too as well. Underscore T. So we now have our init state, which will load immediately that we load the app, and we'll dispose it when we are not making use of it, or when we are finished making use of it. So we now have these two functions. So it's now time for us to call so it's now time for us to make use of the model and let the app make real predictions. The reason why I'm doing copy and paste is the other video I explained all the steps and all the necessary things that you need. So as we have now initialized our model, dispose it when we are not making use of it, let's build our recognition. So I have do this simple copy and paste, which we are making use of our TF Lite. We are running the model on our image. So we are setting the image path, and the image path, as you can see here, so we are calling the image.path, and we are setting our threshold to be 0.1. So make sure that you have all your parameters to be exactly like mine here. Then we need to create a few variables for our confidence and our label. So let's create these variables, which I'll have a string label to be of an empty string, and I'll have a double confidence, which will be 0.0. So let me also make sure that I am calling the same function here. I'm calling the same recognition here too as well. So here we have our recognition. So we are checking if our recognition is equals to null. Therefore, we will make a simple debug which will tell us that recognition is null and we will return. And if everything is successful, right, we are going to debug out the recognition and also set a state for our confidence and the label too as well. So let me bring the TF Lite. Let me cut this one and make sure that I'll put it on top. Yeah, so let me put it on top here and let me save the code. So as we have made heavy changes, I need to kill the app and start the app up again. So yes, our app has started successfully, and let's see that if you'll be able to make a prediction. But before that, let's make sure to change this label text here and let's set our accuracy too as well. So from here, what I'll do is I'll make sure to delete this text that says the accuracy is, and let me delete this one. So here we are checking the accuracy and then we are setting the accuracy to the confidence. And so let's change the label too as well. So let's change the label to the label variable that we created. So let's save this one too as well, and let's pick an image from the gallery to see if you'll be able to make a prediction. So we have this image. As you can see, the confidence level is that 0.1. So with this, right, and if it was supposed to be something like 0.999, then we will have it to be like 99%. So that is the function of this to fix, string to fix. And let's take a different image too to see if the model is working correctly. Yeah, so this is tomato bacterial spots. And the model is working very nicely. I guess this one is tomato healthy. And this one will be pepper healthy. Yeah, pepper bell healthy. So yes, this is how you'll be able to create an image classification model using TensorFlow and converting it to TF Lite so that you'll be able to use it not just in a Flutter application, but also in any type of mobile application. So yes, this is how you'll be able to create an image classification model. Yes, it's very simple. So we started from building our model using TensorFlow. We save it in the form of a TF Lite, and we now have it in our Android application. And with this, you'll be able to build any type of image classification app that you want. The reason why I didn't go much details into the step I was doing copy and paste was I'm having a full video that explain how you'll be able to build it using teachable machine. But calling all these functionalities is exactly the same. So that's the reason why so that is the reason why I just did this simple copy and paste. I hope you find it useful, and I hope to see you in the next video. So thank you for watching, and make sure to follow me in all my social media links, and You can message me if you have any problem personally, and I'll be very happy to help you out. So thank you for watching, and I'll see you in the next video.